the observer design pattern that we just talked about is actually quite restricted to the problem context where you only got one subject and also multiple observers. However, when you generalize the context into multiple subjects and multiple observers, in that case, it becomes quite complex at the runtime for the observer pattern. So this is why we deserve a better design. So now it's time to really introduce a second design pattern called the event-driven design, which is really for us to build a many-to-many, many subjects and many observers relationship using the event-driven design. So that's a new pattern we're going to learn. So that'll be the third part for this lecture here. So this will be the conceptual layout for an event-driven design. Let me talk about its complexity first of all, before we speak about its design in detail and also its implementation in general. So this would be this event-driven design, the conceptual sketch. Let's see. The characteristic property for this event-driven design is for every piece of data you're actually trying to monitor or trying to observe, it has to be of type events. I will talk about what an event is in a moment. In this diagram over here, we only show you the events corresponding to the temperature that we are trying to monitor or observe. You should imagine that there should be another event for humidity, and there should be a third event for pressure, right? All the three pieces of data that we are trying to observe in our weather station example. So now, for every subject on the left-hand side, right, we still, let's say we got n subjects over here. In that case, every subject is going to publish their updates into a single event that correspond to the temperature, right? That's how we think about it. So now the weather data temperature, it is not stored in the weather data objects anymore. Instead, it's going to be a separate event object over here. So that's the fundamental difference. So every subject is going to publish if there's any updates on the temperature into this particular event. It's going to make sure the latest update that's published to the events later on, if it has to be updated to the observer, we can make sure the latest one is really updated to the observer. Symmetrically, for every observer on the other side, we can make sure they actually subscribe to just a single event, basically, right? So now, of course, we got also the events for humidity, we got the events for pressure. So now application 1 should also get subscribed to this event and also get subscribed to that event. So the number of subscription for every application only depends on how many events you have, i.e. how many pieces of data you want to observe, how many kinds of data you want to observe actually. So that's about the publish and subscribe over here. So now what about the complexity? Let's now talk about it, right? Previously, we talked about for the case of the observer model over here, we got m times n links that needs to be built at the runtime. Now, what about the event-driven design? It seems to be drastically reduced for its complexity, right? So you can see we don't need to multiply anymore because there's only a single median over here for the variable being the events. In that case, it will just be a number of links on this side plus the number of links plus this side rather than multiplication. So what we will get is big O of, so number of subjects, so it should be from 1 to, slight typo over here, it should be m. So we got m subjects. What about the number of observers? We got from 1 until n. So m plus n. So now I can contrast with the complexity over there. So rather than multiplication, so now we got addition. So it's drastically reduced for its complexity. Let's think about extensibility, right? So now what about adding a new observer? Whenever you want to add a new observer, let's say I want to add an observer over here. Let's say application, just like that. So now what should I do? Well, previously I need to build all the links, right? If you recall from the previous one, I need to make sure the new observer over here is actually attached to every subject over here on the other side. But we don't need to do that anymore. All we got to do is we're just going to say, in this case, we only got one single event. In that case, we can just say big O of. So now we just make sure we can actually get subscribed to the event that we are trying to monitor, right? So big of 1. So the constant over here basically corresponds to how many events you actually have in your system. And typically it's simply just constant. It's a finite number. So what about adding a new subject. Well, symmetrically, right? So now if I add a new subject over here, that might also publish updates to the events. So I can say WD over here, the new one. Well, all I need to do is I just need to build a connection to the event itself. So that will be big O of 1. Also constant. You can see we got constant, constant versus linear and linear, right? Again, it's drastically reduced for its complexity. However, the only expensive operation we have is like this. What about we have a new event type? For example, let's say here we don't really have the events for pressure, for example. What we can do is we can define add another event here. Let's say change on, let's say pressure of type events. Let's say this is the new events that we want to add. So now in this case, what will be the complexity? Well, we want to make sure every subject can publish to this particular event, right? Every one of them. So that would be basically n. And then we want to make sure that every application is also subscribed to this new events over here, right? So that would be n. So should it be added up or should it be multiplied? Well, seems like only added up, right? But it's still more expensive than the other operation. You can see this big O of n plus n. But I would say it's a very elegant design to solve this general problem where we got multiple subjects and also multiple observers. Conceptually, that's the mental diagram you should have about how things get drastically simplified in terms of the runtime links. You got quadratic versus you simply got linear. Basically, n plus n is basically linear. All right, so that's about the conceptual sketch you should have about this event-driven design. Let's talk a little bit more details about how you can design this and also implement this, basically. Let's go to back to the slides. So these are the complexities that we just talked about. Okay, so now let's talk about how the design can be planned, number one, and number two, we'll see how it can be implemented. Okay. For event-driven design, each variable being observed, for example, temperature will be a one variable, humidity will be a separate variable, and pressure will be another separate variable, like attributes that we used to declare as attributes in the subject class, right, in the second design. It's called a monitor variable. It's a monitor variable is actually a term that we typically use in the cyber physical system. So it's a variable that's being monitored by something else. For example, let's say we have a nuclear power plant. Let's say in Ontario, the Darlington power generation system, where we have to make sure we closely monitor its temperature and also pressure. Okay, let me give you some conceptual idea over here. So because it's applicable, for those of you who are in the software engineering or computer engineering, later on, if you actually want to get a professional license, you want to make sure every product you actually build is safe and fit for purpose. And let's say if you are in the safety critical engineering industry and you have to make sure it's really safe. Safety is really important. Let's say it's a very simple conceptual model over here about, let's say, the plant. Maybe this will be the nuclear power plant over here, right? This will be the nuclear. Safety critical for sure. And then we got sensors and also we got actuators. Okay, sensors means that we simply just monitor. Let's say what we are monitoring is the temperature and also the pressure of the nuclear power plant. And the sensors is actually going to monitor temperature and also monitor the pressure separately. Each one of them will be like a separate events. And then controller is basically, you can think about this could be maybe some shutdown system. The shutdown system is going to make sure, let's say if either the temperature goes too high or the pressure goes too high, the controller should really do something about it. So you should think about the controller. Let's say if the temperature of the nuclear power plant goes too high, it should really send some signal to the actuator so that it can maybe shut down the nuclear power plant, right? That's kind of like an application context for event-driven design when you want to develop safety-critical application. I just want to mention briefly to you. Okay, so now back to the context for our example. Think about the temperature is going to be an event, and pressure is going to be a separate event. And then the plant, you can think about the plant is like the subjects. It's going to publish the updates to these two events. On the other hand, the controller, the shutdown system, is going to be subscribed to these two events. So that kind of corresponds to the diagram that we talk about over here, right? So that's conforming what I just said. Let's go back to the slides. Okay, so you want to make sure it's being monitored by a shutdown system, the observer, and then as soon as the value of these monitor variable exceeds the normal threshold, you should really shut it down, for example, right? So now each monitor variable should be declared as a separate event, as I just mentioned. And observer is attached or subscribed to the relevant events. For example, the current condition app is only interested in the temperature and humidity. That is why it should only be attached or subscribed to the events for temperature and also the event for humidity. And similarly, for forecast, it should only be subscribed to the event for pressure. And for statistics, it should only be subscribed to the event for temperature. Let me just show you, let's say for statistics. If I go back to this diagram over here, think about if I want to add just maybe one more, let's say statistics app. Let me just use orange over here. Let's say I have a new app over here. Let me just call that statistics over here. And then in that case, it's actually going to get subscribed to this particular events, right? That's only one because that's simply corresponding to adding a new observer. Okay, so that's about subscribing the observer to all its relevant events. In case where the app is only interested in one single event, you only subscribe to one. In case the app is interested in multiple variables, in that case, you might subscribe to multiple events, for example, like this. Okay, let's go back to the slides. What about the subjects? So the subject will notify or publishes changes to the relevant event. So it's kind of symmetric operation. Let's go back here. Let's say, for example, let's say these are the two subjects which will actually update. In that case, you will actually update for, the temperature. In this case, they will simply publish the updates to this particular event because it's the relevant event about temperature. And also, this one will also publish to this particular event. And now, as soon as this particular event is actually updated, it's going to somehow reflect the change back to its subscriber or its observer. That's something we'll see exactly how this can be done when we get to the implementation level. Okay, so now up to now we only talk about some conceptual level of the design. So think about we got different events at the middle level, like in the middle, and also we got all the observer on the one side, and we got all the subjects on the other side. That's really important for you to visualize like that. Let's go back to the slides, and now we talk about a little bit more about implementation. Okay, so how do we implement the event-driven design? So these are the requirements. So when an observer object is subscribed to an event, it attaches. So now it does not attach itself to the events, actually, like how we did it in the observer pattern. What it will do is it's going to attach the reference pointer to an updated operation. Think about we simply remember there's an updates routine for every observer, right, in design number 2. So now we're simply just going to attach basically a pointer to that update operation. So what I meant was, if you go back here, imagine that over here, let's say for the SD, for the statistics, let's say we got some updates operation over here, or update command. So what we'll do is the change on temperature events, since SD is actually subscribed to it. So you can think about internally, you actually maintain a list of, rather than observers. No, we don't have observers anymore in this case. What it will really maintain is, for example, this one here is simply going to maintain a reference to this particular update routine. So now it's going to be, when you actually back in your 2031, so the this star over here simply means we want to get the address for the function. Hopefully that's make it easier for you to understand. So we simply just store the updates operation. So later on, if there's any let's say any change from the subject side over here, in that case you will simply just go over all the operation that you actually store over there and then invoke one by one over here. So now, to the reason that we store the address or pointer to a particular update command, it is because for delay execution. So when you first subscribe the observer to the events, you don't really execute the updates command right away. You don't do it. Instead, in order for delay execution, delay only until there's any updates that's published by some subjects. When such update occurs, you're going to execute whatever function pointer that you actually stored previously. That's kind of the idea. Okay, let's go back there and let's see what happened there. And then such reference pointer is for delay execution. So notice that we store the pointer to the update operation, the update command. And itself, so here it really depends on the implementation. So sometimes you may also store the object itself because we talk about OOP, so the context object will be very important. I will show you when we get to the implementation detail, but it's not the same as you simply attach itself to the observers list, like in the second design that we talk about in this lecture. Just try to distinguish between them. Okay, so now symmetrically, what about the subjects? So whenever, as I just explained, whenever you publish and updates to the events, you actually have to, whatever pointer that's actually stored in the events for the update commands, you're going to execute it, right? It's been delayed, so now it will be the time to execute it when there's an updates. Okay, so you will use the operation reference or pointer attached earlier, right? So you can think this part here corresponds to the delay that we talked about previously, right? When we first subscribe the observer to the events. Okay, so now both requirements over here. So these are basically the requirements for implementation. Basically, we talk about, let me just say once more, it's really important for you to understand before we dive into the implementation detail. From the observer side, whenever you try to subscribe, you actually attach basically the update commands of this particular application, and then you simply store a pointer to it for delay execution, number one. Number two, symmetrically, whenever there's any updates that comes from that is actually published from some subjects over here, in which case you will simply let the events go over all the list of delay execution that has been stored previously from all the previous subscriptions actually, and then execute one by one, and that will make sure they'll update all the relevant observers accordingly. So that will be the implementation sketch. So now both requirements for the implementation can be satisfied by IFO and Java. Both of them are possible. So we're going to show you both and let you decide which one you may want to go for. Okay. So we will compare how an event-driven design for the weather station problem is implemented in both IFO and Java using event-driven design, right? So now it turns out it's actually much more convenient to do such design in IFO. Well, it should not be too surprising to you because IFO is a design language, but it doesn't really mean Java is not good. I'm just saying for you to think about the design for event-driven architecture over here, it's much easier, much more convenient for you to think about the design in IFO using agents. On the other hand, in Java, because it's much more implementation oriented, even though you can get a programming to work, it's just much less convenient to think about all the bits and pieces. Okay, so now for the rest of the lecture, we're going to go over the Java version first, followed by the IFO version.